Hello everyone, my name is Rahul Mandal, USN 1V20CS124, and today's topics are 2D pipeline, 3D pipeline, RGB and CMY color model. So starting with 2D pipeline, we have this diagram: 2D object data, object transformation, window transformation, clipping, viewport transformation, scan conversion, frame buffer, computer display. In computer graphics, a 2D pipeline refers to the series of steps involved in rendering a 2D image on the display screen. It, encom- it encompasses various stages that transform geometric objects and their attributes into final 2D image that can be displayed on the screen. The typical stages in 2D pipeline include: A. Modeling. This stage involves defining the geometric shapes and attributes of the object to be rendered. It can include creating or importing 2D shapes such as lines, curves, polygons, and text. Next one is transformation. In this stage, the objects are transformed from their original position and size in the virtual 2D space. Common transformation includes scaling, rotation, translation, and sharing. The third one is clipping. Clipping is the process of determining which part of the object are visible within the boundaries of the display screen. It involves discarding any geometry that falls outside the viewing region. The next one is rasterization. Rasterization is the process of converting the geometric shapes into raster image, which is a grid of pixels. Each pixel is assigned a specific color or other attribute based on the properties of the object being rendered. Next is shading. Shading involves determining the color or intensity of each pixel based on various factors such as lighting, material properties, and surface normals. It adds realism and depth to the 2D image. Next one is texturing. Texturing involves mapping a 2D image called a texture onto a surface of the object. This adds details and enhances the visual appearance of rendered image. The next one is composition. Finally, the individual objects are combined together to create a 2D final image that is displayed on the screen. This may involve blending multiple layers, applying transparency effects, or other operations. Now we'll see 3D pipeline. Here's a diagram for general 3D viewing pipeline. A 3D pipeline, also known as a graphics pipeline or rendering pipeline, is a sequence of stages involved in rendering three-dimensional objects and scenes into a 2D image or animation. It encompasses the process of transforming 3D models and their attributes into a visually realistic presentation. The stages in the typical 3D pipeline include modeling. Similar to 2D pipeline, the stage involves creating or importing 3D models of the object or screen. These models define the geometry and attribute of the object such as vertices, edges, faces, textures, and material properties. The next one is transformation. In the transformation stage, the 3D model undergo various transformation including scaling, rotation, sharing, etc. Next one is clipping. Clipping in the 3D pipeline involves determining which part of the object or scene are visible within the viewing system, which represent the portion of the 3D space that is rendered on the screen. Next, we have projection. Projection is the process of mapping a 3D scene onto a 2D surface, such as display screen. This involves transforming the 3D coordinates into 2D coordinates using technique like perspective or orthographic projection. Next one is rasterization. Rasterization converts the 3D primitive like points, lines, and polygons into a raster image composed of pixels. It involves determining which pixels are covered by primitive and assigning attributes like color or depth to the pixel. Next one is shading. Shading calculates the color intensity of each pixel based on the factor like lighting, material properties, or surface normals. Next one is texturing. Texturing involves the mapping of 2D textures onto the surface of 3D objects to add details and enhance visual appearance. This can involve technique like UV. Next, we will see RGB color model. So here is the diagram of how RGB color model look like. So the x-axis represents the color red, the represents the color green, and the z-axis represents the color blue. The RGB color model is an additive color model where colors are created by combining different intensities of red, green, and blue light. In this model, colors are represented by specifying the intensity of each primary color component. The primary color red, green, and blue are typically represented by values ranging from 0 to 255, where 0 represents no intensity and 22 to 255 represents maximum intensity. By varying the intensities of red, green, and blue, a wide range of colors can be created. For example, when all three components are set to their maximum value, that is 255, 255, 255, it produces pure white light, while setting all components to their minimum value, that is 0, results in black. The RGB color model is widely used in computer graphics display and digital imaging devices such as cameras, scanners, and monitors. Most digital images, including photographs and computer generated graphics, are stored and processed using the RGB color model. Next one is CMY color model. So here is the diagram for CMY color model. Here the X axis represent cyan color, the Y represent magenta, and the Z axis represents yellow. And combining these three colors, we can get red, blue, and green. The CMY color model is a subtractive color model used in painting and mixing pigments. It is based on the concept that when light passes through or reflects off ink or pigments, certain wavelengths are absorbed or subtracted, resulting in the perception of a color. In this model, colors are represented by specifying the intensity of three primary colors component, that is cyan, magenta, and yellow. The CMY model is often extended to include a fourth component, black, resulting in the CMYK color model. The addition of a black allows for better control over color reproduction and improves the representation of shadows and dark areas. The CMY color model is primarily used in printing, where inks of different colors are overlaid to create a wide range of colors. It is also used in color mixing system for paints, dyes, and other pigments. In computer graphics, the CMY color model is often used for color representation in the print oriented application, while the RGB color model is used for digital display and web based content. So these were the topics which are discussed in this video. Thanks for watching.